At 6:15 on the morning of June 6, 1944, Gefreiter Heinrich Severloh crawled into position behind an MG-42 overlooking Omaha Beach. He was 20 years old, a farmhand who had never fired at a human being. Below him, 5,000 ships carried 156,000 American soldiers toward the sand. Over the next 9 hours, the weapon in his hands would fire 12,000 rounds and change the course of D-Day. But the story of how that weapon came to exist is even more remarkable than what it did on that beach. The MG-42 wasn't designed by Germany's legendary arms manufacturers. It was created by Werner Gruner, a 33-year-old mechanical engineer who had never served in the military, never designed a weapon, and worked for a company that made sheet metal lanterns. When Metallwarenfabrik Grossfuss received a contract to develop Germany's next machine gun in 1937, the established weapons industry laughed. Lantern makers competing against Rheinmetall and Steyr. It was absurd. 3 years later, Gruner's design would revolutionize warfare. 80 years later, it still defines how every army on Earth thinks about machine guns. The problem began with perfection. Germany's MG-34, introduced in 1934, was the world's first universal machine gun. One weapon serving as light machine gun, heavy machine gun, anti-aircraft gun, even aircraft weapon. It was a masterpiece, beautifully machined from solid steel, precision-fitted parts. German officers were proud, but perfection was expensive. Each MG-34 required 150 hours of skilled machining, one weapon per craftsman per month. The cost was 327 Reichsmarks, more than 2 months' wages for a factory worker. It consumed 49 kilograms of high-grade steel alloys Germany had to import. Wehrmacht planners did the math. They needed tens of thousands of machine guns. They could afford perhaps a few thousand MG-34s annually. In February 1937, the Army Weapons Agency issued a desperate request. They needed MG-34 performance at half the cost and half the production time. 3 companies received contracts. Rheinmetall Borsig, Germany's premier weapons maker since the 1800s. Steyr, Austria's legendary manufacturer. And Grossfuss, the lantern factory in Lower Saxony. The weapons companies approached the problem like weapons designers. Simplify the MG-34. Remove unnecessary features. Optimize machining. Gruner approached it like a manufacturing engineer asking a completely different question. What if we don't machine it at all? What if we stamp it from sheet metal like we stamp lanterns? The weapons experts declared it impossible. Machine guns generated enormous forces. Thousands of pounds of pressure, repeated hundreds of times per minute. Stamped sheet metal would tear itself apart. Everyone knew machine guns had to be machined from solid steel. Gruner didn't know enough about weapons to understand why it was impossible. So he did something weapons experts never considered. He enrolled in a German army machine gun course. For 3 weeks in summer 1937, this engineer who had never held a rifle trained alongside infantry. He fired thousands of practice rounds through the MG-34. He learned what actually broke in combat, what frustrated experienced gunners, what took too long to fix in the field. The MG-34 was a machinist's dream and a soldier's nightmare. He returned to Dubin with a radical insight. Traditional machine guns were made by removing material. A machinist started with a steel block and cut away everything that wasn't the part. Slow, expensive, wasteful. Most steel ended up as shavings. Stamping worked differently. Press flat sheet metal into 3-dimensional shapes using hardened dies. A hydraulic press formed complex shapes in seconds. Minimal waste. Unskilled workers could operate it. A flat sheet went in. A finished component came out. Working with designer Kurt Horn, formerly of Mauser, Gruner developed a revolutionary design. Only critical components would be machined: barrel, bolt, high-stress parts. Everything else stamped, pressed, riveted, spot welded. The design used a roller locking system instead of the MG-34's rotating bolt. 2 rollers engaged barrel recesses. When fired, rollers prevented the bolt from opening until the bullet left and pressure dropped. Then rollers cammed inward, unlocking the cycle. Elegant, reliable, perfect for stamped construction. By October 1937, all 3 companies submitted proposals. Rheinmetall and Steyr offered conventional designs with improved machining. Grossfuss submitted something that looked crude, almost improvised, visible spot welds. obvious stamping marks. It looked cheap because it was cheap. The evaluation board was skeptical. Then they fired it. The prototype performed flawlessly. Less sensitive to dirt than the precision MG34. It tolerated abuse that jammed the temperamental MG34. When deliberately fouled with sand and mud, it kept firing. Stamped components flexed under stress rather than cracking. Looser tolerances actually helped. It functioned when conditions would stop a precision weapon cold. The production numbers were staggering. MG34 required 150 man-hours. Grossfuss design required 75, half the labor. MG34 consumed 49 kilograms of materials. New design used 27.5, nearly half the steel. MG34 cost 327 Reichsmarks. New weapon cost 250, a savings of 77 Reichsmarks per weapon. But cost savings came with something terrifying. The new gun fired 1,200 rounds per minute, 20 rounds per second. At that rate, individual shots were indistinguishable. The human ear couldn't process it. Instead of familiar machine gun rattle, it produced continuous tearing sound like heavy fabric ripping apart. This was deliberate. German doctrine emphasized suppressive fire during brief moments when soldiers moved between cover. Maximum bullet density in those seconds was life or death. At 1,200 rounds per minute, the bolt traveled back and forth 20 times per second, faster than the eye could follow. Gruner's team designed a quick change barrel system, 6 seconds to swap. A lever unlocked it. Gunner wore asbestos glove to grasp the hot barrel. Fresh barrel slid in and locked automatically. In early 1942, the design entered service as Maschinengewehr 42. The MG42. First combat came May 1942 in North Africa at Gazala. British troops encountered something unprecedented. A machine gun sounding like cloth ripping, like a buzzsaw cutting wood. British called it the Spandau. Americans called it Hitler's buzzsaw. Soviets called it the linoleum ripper. Germans called it Hitlersäge or Knochensäge, the bone saw. The psychological impact was severe. Nothing in Allied training prepared soldiers for a weapon screaming continuously. Veterans described visceral, gut-level fear, but reality was worse than sound. A 30-second burst put 600 bullets downrange. Against exposed infantry, results were catastrophic. On June 6, 1944, Heinrich Severloh demonstrated its capability. His position sat 40 meters above Omaha Beach, with clear fire across 2,000 meters of sand. When Americans hit the beach at 6:30, Severloh pulled the trigger. He fired controlled bursts, sweeping the waterline where soldiers struggled through chest-deep water. His assistant fed belt after belt. When barrels grew hot, they changed them. When ammunition ran low, soldiers brought more. Americans had no effective response, wading through water, carrying 60 pounds of equipment, seasick and disoriented, waterlogged rifles. Naval gunfire had missed German positions. Severloh fired for 9 hours. He later recalled stopping thinking of shapes as men. They became targets. The MG42 made it possible to engage so many that the mind retreated from horror. He fired approximately 12,000 rounds. His position was responsible for a significant portion of the 2,000 American casualties that morning. The weapon reshaped German infantry tactics. While Allies emphasized the rifleman, Wehrmacht built squads around the machine gunner. The MG42 was the center of every engagement. Riflemen carried ammunition, protected the crew, finished suppressed enemies. Typical crew was 6 men. Production ramped dramatically. 76,000 in 1942, 116,000 in 1942. After the war, American engineers studied captured MG42s extensively. They noted the reliable feed mechanism, superior quick change barrel, stamped construction proving precision machining wasn't essential. The resulting M60, standardized in 1957, borrowed the feed mechanism directly. The philosophy of stamped steel came straight from Juban. The M60 served through Vietnam and beyond. The Belgian FN MAG, adopted as the M240, owed design debt to the MG42 concept. The general-purpose machine gun philosophy came directly from the German universal machine gun. Today, the M240 serves as America's primary medium machine gun. When West Germany rearmed in the late 1950s, they wanted the MG42, but original documentation was captured by Soviets. Factories were destroyed. They reverse-engineered it from museum examples. An MG42 obtained from America was disassembled completely. Engineers measured every component, created new drawings, designed new tooling. The result was the MG3, almost identical to the original. Parts between wartime MG42s and modern MG3s are interchangeable. The MG3 has been produced by Italy, Greece, Iran, Pakistan, Spain, Turkey. Over 1 million manufactured. More than 40 countries used variants. 80 years after Gruner submitted his prototype, weapons descended from his design remain in active service worldwide. Werner Gruner survived the war, became a professor at Technical University of Dresden in East Germany, trained new engineers, received numerous honors, died in 1995 at 91. His obituaries mentioned his academic career, but not the weapon that killed tens of thousands. Heinrich Severloh survived, was captured after D-Day, returned to farming. For decades, he didn't speak about Omaha Beach. The memories haunted him with nightmares. In 1963, he read about David Silver, an American shot 3 times at Omaha, who survived and became a Catholic priest. Severloh tracked him down. The two men met and found peace, acknowledging each other's humanity. Severloh died in 2006 at 82. The MG42 proved that expertise in a specific field matters less than problem-solving ability. A lantern factory created one of history's most effective weapons by asking different questions than weapons experts. Sometimes the best solutions come from outsiders too ignorant to know what cannot be done. If you found this story compelling, hit that like button. Subscribe for more engineering deep dives. Tell us where you're watching from. Thank you.